and today we have a very important topic. I suggest everyone pays great attention because functions, not only in JavaScript, but in pretty much any programming language which supports functions, procedures, etc., is very important. So I'm going to start with some snippet of code, which we'll be repeating a couple of times, and then we'll see where the functions come in and how they can help us to kind of separate our code into some small snippets that can be reused throughout our code base. And in that way, we do not have to repeat ourselves too many times. We can just define this snippet in one place and just reuse it everywhere. Okay, so let's maybe start with something like this. Imagine we have an array of numbers, right? So we start with an array of numbers. Let me check that the recording started. It did, and the screen is shared. Okay, so I'm going to create an array of numbers, right? So 1, 2, 3, 4, and 5. So that's it for now. This will be an arbitrary array of any elements in the future. However, for the sake of this example, I'm going to create an array of numbers. So what we're going to do next, we're going to just do some for each on this. And then I'll say, no, let's not do the function here. Let's do for of. Let element of array of numbers. And what I'm going to do, I'm just going to simply console log my elements. Okay, so simple enough. Nothing kind of complicated there, and we can see that our elements are logged. Okay, so what else can we do? Maybe we would like to also log the index. Okay, let's try to do that. What function can I use on an array? Okay, no, but let's not complicate things. Let's not kind of drift into another direction. So let's just keep it simple. We're trying to simply log this thing. Okay, so where I just put it here, I'll just say about to log the elements of the given array. Okay. No, like this. So this is my snippet, start of the snippet, and there will be also an end of the snippet, right? So, okay, this is simple enough. So we're just logging something there. What if we have another array? We have an array of strings. Hello, there, what is, okay? What if I want to log the elements of this array? So what I will have to do, I would have to, again, let string element of array of strings, right? Let me make this in uppercase. And then I will have to, again, do console.log element. Okay, so, and if I would also like to just keep it very similar to what we had with the numbers, I would also bring this console log here, and as you can see, we have the same console log here and here. These are just two kind of snippets. We have the same logic of iterating through our array and doing something with the elements of the array. So as you can see, the contents of the arrays of these arrays are different. However, the logic itself is very similar. So there should be a way to kind of abstract this logic to somewhere and maybe use that logic on the array itself. And this is where the functions come into the play. So you can imagine that functions in JavaScript are these reusable snippets where you can define your logic and use and reuse that logic in your application, in your Cypress code, whatever it is, in your source code. So and arrays usually have inputs, and sometimes they provide out. Functions sometimes have inputs, and sometimes they provide outputs. So let me go to the drawing tool, and let me just grab this square tool. So we will have some kind of input. Let me make it small and slightly bigger. Okay. My function. So this is the name of the function. Okay. So my function is the name of the function that I have created in this drawing tool, and then my function can have some input, and it can also have some output. It may have an input, it may not have an output, or it may not have an input, but it may give an output. So you can kind of combine things together here. So none of these parts is kind of mandatory, but your function can have inputs or input, and can have output or outputs. So what do you think in this case, for this specific case? What is the input for that reusable kind of
array of numbers?
So it will be not an array of numbers, but just an array of any elements, right? Because on these lines, we just have another type of array, which is an array of strings, and we are still console logging stuff. So
it's parameter.
Yes. So the way we define these reusable snippets of code, which we can just create somewhere and reuse in other places, we have a reserved word in JavaScript. Is called function, unsurprisingly. So this is the way we would define our function called my function. So we would say function. Okay, so it's like kind of const hello. So this is something like that, right? So we're telling our interpreter, our JavaScript interpreter, hey, what we are about to create this reusable snippet of code. And that's why we say function. So function, my function, then we give the name of the function, and we have parentheses and square brackets. Now, where the input comes of this function, as we see, we have these parentheses. So the input of the function goes into the parentheses. So if I, in this case, if I expect an array of elements, right, of any array, I would just say array, right? Now, this is my input. I will be doing something with this. Now, what I will be doing with this, I will just simply console log, right? As we have this console log for both of the parts of the code. And then what we have is we have a for off loop, right? So I'll just put it here, and I'll say element, because now we do not know the type of the element. It can be pretty much anything. So I will not be naming my variable here as string element, because in another example, it can be just an object. The element of this array can be an object. So again, let's put it here. And that's pretty much it. So now what we can do is we can create an array of booleans. Okay, for example, true, false, and true. And then the way we invoke our function and pass our inputs to this function is we specify the name of the function and then put these parentheses and then provide the input to the function. Okay, does that make sense? So in the definition, we have function, the name of the function, in the parentheses, we provide the inputs for that function. And the way to call it is again, very similar to this part of the definition. We just write down the name of the function, and in the parentheses, we provide our inputs, our input or inputs. Okay, so yeah, let's just save and see what it does. So it just went ahead and did the job, right? So now what we can do, we can basically grab this array and call our my function here for this array and remove this part and remove also this part and call my function for array of numbers and also remove this. And now you can see how greatly our code was basically simplified. Because now we define our logic, which works on the array in this case, and then we use that logic wherever we need that same logic. So we did not have to repeat the console log of this. We did not have to write 3 4s, whatever it is. So that's cool. We kind of reused the logic. We defined this snippet in one place and we reused it in 3 other places, and we can reuse it however many times we want. Now, another additional kind of nice to have thing is that imagine I still kind of roll back to the 4s, right? So we still have 4s. What if I have a typo in the console log? So I created this first part. There is a typo or an error in the logic. Okay. So what I do next, instead of digging into the code, I just copy paste things, because that's what developers basically do. You usually copy paste stuff because you don't have time, etc. Whatever. So we'll leave a bug. There's a bug in here, right? So the typo, it's a bug. So what we do next, we just kind of copy paste everything and just change the input array, and that's it. But imagine that if we would copy paste this into 15 other places, we would have the same bug in 15 other places. And now when we come to functions, as you can see, since we reuse our logic, right? So I'm just going to refactor this quickly. Okay, so and the array of numbers. We don't need this at all anymore because we have functions, and array of Boolean, again, let's call it here. So we still have the same things working, but now if we have the typo in our function, as you can see, it's kind of propagated into all our use cases. And now when we fix the typo in one place, see the strings on the right side and save it, now the issue is fixed in all these 15 places that the function is used. So this is the power of functions, right? So when you have a logic which you think can be reused, put them in functions. Even if you have a bug in the logic of your function, if you fix that in there, it will be fixed pretty much anywhere else. That is why usually all kind of date and time related methods are put in functions. I'm just giving you some practical examples. In my project in FleetPro, I also created a date and time kind of snippets functions, because we have our own way of showing our dates and times. So to not have to format my time and date in every single place manually, and for example, in 5 months, the format of the date changes, I'll have to go through all my code and update it. But since I've created a function, I can just go to that function, update the format of the date there, and it will be updated in the whole application. So this is the power of functions. Now let's talk about functions. Yeah, let me see what we have here. Okay. So what happens if we provide an empty string? Nothing. What happens if we provide 0? We have an error. Okay. What happens if we provide false? Nothing. Okay. So so what I did here, I gave 0 and false to this function, and everything broke down. Why? Because we are trying to to invoke the for of kind of loop on a Boolean, but the Boolean is not an array. in this case, right? So it will break and it breaks. So is there a way to check if the variable holds an array in JavaScript?
Array is array.
Correct. So maybe what we can do here, we can add some additional guards, right? So as we are expecting an array, but so an important thing to understand, even if you create a function which expects an array, there is no guarantee that you will always get an array, right? So then you will have to start to think about some use cases and to kind of guard your logic. Okay, so this logic works in this case only when we provide an array to our function. So we should somehow check that their input value, that our input argument is an array. So the way we do it is is array. Okay. Is this now? Okay, so what we log here is about to log the element of the given array, but I think that this is not really correct, because if the input value is not array, I think we should not log this. So let's put this into the if, and in the else we'll say console.log, make sure the input to this function is an array. Okay, so now we can also hint to whoever calls this function that you did not call this function with an array, so go check your code. We can do something like this. Okay. So let's talk maybe also about the optional arguments and default values. Now, when we're calling a function and we are not specifying any parameters, now, as you can see, TypeScript is trying to be smart here, and it helps us out and says, and it sees that, yeah, as you can see, it's TypeScript. So it sees that when we defined our function, we said that we are expecting at least one argument to be received. But here we did not pass any kind of arguments. So TypeScript said, you've got an error here because this function expects an argument. So I'm going to maybe suppress this error to be able to write the code to show it. Now, as you can see, we still are in the else part of the logic. But what do you think is the value of the array in that case, if we did not specify anything here? So the way we check it, let's do console log, the input argument is, what do you think the array will be in this case?
Undefined.
Correct, it will be in undefined. So if you do not specify anything to your function as an input, the very first argument will be an array, or pretty much any argument will be an array. Sorry, it will be in undefined. So that's that. Is there a way to maybe provide some kind of default value to our array? Maybe if we can check if the array is undefined, then we could create some kind of default value. What do you think the default value for this array variable should be if we do not receive an array?
Array?
Correct. That would be an empty array. If this was is hotel room available, what do you think the kind of default value for this type of variable would be? Boolean, correct. And why should it be Boolean? Is, right? So as you can see, I'm using some semantics here, right? I'm trying to hint myself, the future myself, when I read this code like in 3 months, that I could have named this an X or Z, whatever. I can do this. This is valid JavaScript. However, in 3 months, if I read this code, I still need to understand what this function does by just looking the name, what this argument is about by just reading the name of the variable. So you can, of course, do something like this 1, 2, 3 dot map x, whatever. You can do this, okay? Or z, or blah blah. You can do this, but this is not recommended for you. It's for your sake. Try to keep the naming of your functions, variable, whatever it is, semantic, logical. Just write English words. Don't be concerned that the name of the variable is long. Just for your sake, make the code in a way that in like 3 months, if you would read the function, you would still understand it. Or also try to think about it this way. What if someone else reads your code, right? The people will be doing code reviews on your code. So instead of just saying X and putting some Boolean value in the X, which is valid JavaScript, however, you could have done this better. Just name it something like this. Is this available? Has value changed? Whatever. Just kind of try to hint or indicate that this variable is going to hold a Boolean, a string, or whatever it is. If we would say person name, I don't think anyone would expect that the value of this variable called person name would be an array or object or a Boolean or a number. So it is logical that you expect that there should be a string here. Anyways, semantics. So what I was getting to, now we have a case where the input argument is undefined. How can we do so that still, even if the input argument is an undefined, we still operate on an array? So the way we do that is we create another variable inside our function, and we check the value of the array. So what I'm going to do here is I'm going to use the ternary operator. I hope you are familiar with this. If not, I'll explain how it works. So the way it works, let me just write it down and I'll explain how it works. So if array is array, then we return array. Otherwise, we return an empty array. So the way the ternary operator works, so in the first part, we have our condition. Okay, so we can do something like this. If the input argument, if the value of this input argument is an array, then we return whatever came to the function. So that's good. For any other options, right? So it's this else kind of part. For any other type of values, objects, strings, Boolean, class, function, whatever it is, whatever comes else, we return an empty object. So in this case, let's go ahead and console.log inner array. Okay. Now, as you can see, our inner array is an empty array. So now, instead of using this array input argument in every place, we can just simply do this and do this. However, we can improve here slightly. Now, if we kind of guarantee that our input value is an array, do we need this part? No. Do we need this? Because in any case, we guarantee that our inner array is an array. Of course, if we have some string coming in, we're kind of ditching the value of the string and using an empty array. However, it's not the point of this example. So in this case, what we can do is we can just remove this if else, because we kind of get on line 11, we basically guarantee that our inner array is always an array. So in that case, we can do this. Now, now the other problem here is that we are about to log all the elements of the array, but there are no elements in empty array. Does it make sense to log anything that is empty? It does not. So how can I do so that if my array is empty, I will not do anything.
Just leave.
Length is 0, yeah. Length is 0 of array.
Okay, so what I can do is I can say inner array dot length. I may not even check if it's strictly 0. Of course, I can do this, but I will not do it because if the length of the array is not 0, then we will be in this if statement. If the length of the array is 0, we will not be this code will not be invoked because let's also talk about that since we're here. So 0, false, empty string,
Undefined.
undefined,
No.
undefined, null, zero, false, empty string, undefined,
No.
null. These are so-called falsy values. Anything else, truthy value. Now the okay. Now the way if works in JavaScript, if in this if statement, no. Dekorators testem niciun greu. Bez banareți arțut. Kana zume mare, iesarčam test. So it's 0, false, empty string, undefined, null. I think you said there is the 6th one, but I'm not sure what's the 6th one. So
Maybe null and then
oh, that's a
I
good
don't
point.
think
Yeah, that's a very good point. Maybe NaN. Yes. Yeah, that's a very good point. So 0, let's put also NaN because what is the type of NaN?
number.
Number. That's why I put NaN close to 0. So 0, allegedly also NaN, we'll check that, but most probably it's also a false value. Then Boolean false, which is a true Boolean, empty string, undefined, null, 6 values are so-called false values in JavaScript. Anything else, empty array, empty object, empty function, non-empty function, non-empty strings, any other numbers, everything else is a truthy value. And what does the falsy value or truthy value? What's that? What's the truthy or falsy part? So when we use the values in our conditions, we might not only specify Boolean values, but we can also specify any other values. And that's when the concept of truthy and falsy comes into the play. So as you remember, I said that we can do something like this, or rather we can check if our array is not empty, which is if the length of the array is 0, we consider it as empty. So we say if inner.length is not empty, meaning if our array is not empty, then go ahead and do the for loop. Otherwise, it doesn't make to do any for off loop on an empty array because we will not be logging. An empty array doesn't have any elements anyway, so that doesn't make sense. However, what we can also do, we can skip this part because let's discuss a couple of options, okay? So what if the inner.length is 0? What is a 0? It's a falsy value. And then we will not be invoking the if. Do not invoke if. Well, invoke is a kind of metaphor here, okay? So when I say we will not be invoking if, it means we will not be executing the code that we put in, okay? What if the length of the array is 1? It's a truthy value, truthy value. What does this mean? Do invoke if. So if the value, if the condition or the value we give to our if statement, if it is truthy, we do whatever we write in if. If it is a falsy value, we do not do that. And let's also quickly check the NaN.
Yeah.
It's a falsy value. Nice job. So 6. So remember this as falsy values, okay? So if you give some for any falsy value to your if, or also ternary operator, so if we would put 0 here, we would get an empty array because 0 is a falsy value, and falsy values work kind of the same way both for the ternary operator and the and if statements, like whatever, and also switch statements, any kind of conditional statements we have in JavaScript, both falsy values and truthy values operate the same. Okay, so that's about, let me put this in the Telegram group. Okay, so in this case, basically, we kind of guaranteed array.isArray that our inner array is also always an array. However, there is a shorter way to do that. In JavaScript, starting in, I think it was 2015, I'm not sure. Starting, imagine in 2015, the ECMAScript 6 standard, we can also specify some default values to our function arguments if the value of that argument is undefined. So in this case, since we did not specify anything to my function, the value of the array is undefined. And in that case, we can do this. We can say, if we are not passing any value to this array, just put an empty array inside that variable array. So now what we can do, we can just remove this, we can remove this, and we can say array. Now this would be a shorter kind of way to do this. Okay. So, and that's about the default arguments. Now you can also say if we do not pass anything here, I want the initial value. Think about this as initial values. I want the initial value of array to be 1, and TypeScript also gives us an errors here. Yes, go ahead.
So we put there as a default value empty array, but if we pass a string, effectively we give the function value.
Correct.
But it will not get empty array.
Correct. Yes, the code will break.
The string has length, yes.
Yes.
So
but
it works in this way.
No, it's up to us to decide whether we want it to work. We can pass a string, and it will still work.
Yeah.
In this case, and that's a good example you brought up, because I'm not going to explain this, but strings and arrays are so-called iterables, and iterables in JavaScript. Imagine iterables are these data structures where you can use the for/off loop to go through their elements. So anything in JavaScript that is an iterable, you can use this for/off loop to go through their individual elements. In case of the array, it's the elements of the array, but in case of the string, it's the individual characters of the string. So in this case, in this particular example, everything will still work, because both strings and arrays are iterables. However, if we would go for a number, now this would break because we do not have the dot length property on the number, and we cannot do the for/off on the number too. As you can see, we have the errors here. it is up to us as developers to decide whether this logic should only operate on arrays, or this logic can also operate on some other types of data. Now, in this case, since both arrays and strings are iterables, this exact same logic can work for both of them because we have dot length on both strings and arrays, and we can use for of on both strings and arrays. So what we can do is we can simply check if the incoming variable, we may say array or string. And in this case, if we might receive two different types of values, it is not kind of that logical to initialize the value as an empty array. We may decide to do so. It's up to us developers. However, we may not also do that. In this case, if you are also expecting to receive multiple types of values, you usually also need to check if your value is string, then do something, so slightly different logic. If your input value is an array, do something else. So that's also valid JavaScript. We do that quite often also normally. Okay.
Can we call as a parameter another function name?
Yes. Okay. And I'll show you an example. Now let's create another function. What I was going to talk about was this first kind of point, which says that functions are normal values in JavaScript. Correct. Reduce can be one example. Like all of the array methods, all of them receive functions, and that already shows that functions are normal values. However, what I will do here, I will create another function, and I will use this might function to do something in that function. Now let me create another function. Let's call it runner. This is, it will not receive anything. By the way, if the function does not receive anything, and you still call this runner function with a value, of course, there is no variable name to get the value. However, there is still a way to get your input values in this type of function. But more about that maybe in classes or we shall see. That's not super valuable. Currently, we do not usually do that normally. So I'll show you to just know that there is something like that, but it's not that kind of valuable. So let's keep it for now. Okay, I was going to create the function called runner. My function runner expects another function. So fn, let's call it short way, okay? Fn. So usually you name it, your callback functions fn or callback fn or whatever. So this fn kind of indicates that whatever is passed in this argument, it should be a function. Even if you pass a number, you kind of expect it should be a number, but this does not mean that the value itself is a function. Anyways, so we say, we define our argument, we name it as callback function. Now what we do is we create an array of, for example, numbers, okay? So 1, 45, whatever. Now what we do is we treat the value inside this variable or argument, let's call it argument, callback as a function. So I treat it as a function. I specify the parentheses, which means I treat this, whatever this callback function is, as a function, and then I pass my array into that whatever I treat as a function. Okay. But of course, this does not do, as you can see, does not do anything, because for the function to do anything, we need to call the function. We need to invoke the function. So on the next line, I'm going to say runner. And what I'm going to pass as the first argument is my function. Okay?
Mm-hmm.
So let's save it.
Mm-hmm.
Now, as you can see, the runner expects something called callback function. It defines an array inside itself, and then it treats this callback function, whatever it is, as a function, parentheses, and passes array of number to that, whatever it is we treat as a function. So this example shows that functions are normal values that you can pass around other functions, other code. So we could just very easily say runner one, right? So one is a normal value. Hello string is also a normal value. Array is something very normal we are dealing with. But it also turns out that functions are also normal values. You can pass them around in JavaScript. These not all languages support this, okay, to pass around your functions as normal values. JavaScript does, and it's very powerful, as we will see when we get to asynchronous code execution. By the way, if you recall, on the very first day when I was doing the introduction, I was talking about the synchronous way of executing code, asynchronous way of executing code. Up until this point, and maybe the other session, whatever we executed is synchronous. If you go from top to bottom, from line 1 to the very first to very last line, as you read your code from top to bottom, that's how your code will basically execute. Okay, so now we know that we can pass functions into other functions. Functions are normal values that we can pass around, which is pretty cool, and it's very powerful. Now, types of, yes. Now, let me explain how this will work, okay? So we defined our function called runner, which expects callback function. Now, the way the execution will work here when we call this line 29. So we're on line 29, we call runner with my function. We pass callback function to this. This is still synchronous, no asynchronicity here. And our callback function receives array of numbers. Now, what do we have in this callback function? Can anybody spell what we have in the callback function? My function, yes, too easy. So we passed my function in callback function. Now we specified now, and then we pass this array of numbers as an argument to callback function. Now we jump here because we invoked our callback function, and what callback function is here in this scope, it is my function. So it is like we passed this array of numbers into our my function, and then we start executing our code from top to bottom. So it's jumping around, jumping to this part of the code and this part of the code, but it's always synchronous. Okay, so it does not kind of try to do anything in parallel, well, not parallel, but in an asynchronous manner. We just simply jump from one part to the other, execute this code kind of synchronously, jump to the other part, execute the code synchronously, and jump around and do the job. So that's about that. Now, what we can also do is we can create a constant, right? Let's say hello function, and we can put our function into this variable where we can say console.log hello there. Okay, now when we invoke hello function, now this works. So there are kind of two ways, right, to use this function keyword. So the first one is we simply say function, whatever the name of the function is, parentheses and arguments. The other option is we use our normal variable declaration, and we say the name of this function is hello, which is basically the name of the variable. And then we say equal, well, not equal, then we have the assignment operator, and we assign this unnamed function, unnamed because we don't have a name here. And then we assign this unnamed function, put this unnamed function into the variable called hello function. And then the variable hello function holds the reference to this function, and we can still invoke hello function with the parentheses. Okay.
Which will write in function. Is working.
It's not about better, but there are some differences which I will not be going into. One of the differences is hoisting, as our colleague knows. But my recommendation would be for you to use this type of function declaration, this one, and you will be on the safe side of the things. So if you just want to pick one way, you can keep it consistent. I usually don't do this type of function declaration. This is a kind of expression, and this one is a declaration. There are differences between them, but we do not need to talk about the differences because that's a big topic by itself. It's called hoisting in JavaScript. If you're curious, you can look it up. Hoisting in JavaScript. Yes, hoisting, H-O-I-S-T-I-N-G.
Ask another question about the parameter we pass into the function. So, for example, if it is a number or some primitive data type, so does it makes declares a variable and sets the value in this variable? For example, in this case, callback function, we pass here a callback function. Does this callback fn parameter name becomes like a variable and it gets a reference to this function? Correct.
It becomes a variable. So, okay, another advanced topic I didn't want to discuss. Yeah, let me just finish the example with hello and I'll get to that. But I really do not want to explain that because that's an advanced kind of. I'll answer, since if the question comes up, I will answer the question. I will not leave your question unanswered. However, this is an advanced topic which is not for these lessons, okay? Okay, so what I was saying, hello, okay, yeah, hello function. So this is the second way of kind of declaring functions. Now, now let's come to your question and then I will get to array functions. Okay, so two types of variables that we discussed in the previous session, primitive ones and referential ones. Can you remind me which are the primitive ones?
Numbers, strings, booleans.
Okay, strings, number, boolean, symbol. Okay, 4. Now, can you remind me the referential ones? Functions. 3. Arrays, objects, functions. And what happens if we have two variables and we have primitive values in these variables? What happens when we compare them?
They compare the exact
values
during
the
reference, the address of
Reference?
values.
No reference?
It's how to say the memory stack, yeah? It goes and compares its like reference stack or what we were saying. That
So we
it's in the memory.
We have two variables and we have primitive values in these variables. Now we're comparing these variables together.
Yeah.
How do they get compared?
It was
My values.
references.
No, values.
Okay, but the references were the same, yeah?
No. They're not the same. They might not be the same. If you would.
But the same, no, but the same, okay. If we have like empty arrays, the references can be different, but the same value have the same reference, yeah? For example, the
same.
value is 5, the references are the same.
Why should they be the same?
Okay, no. Okay.
So let me open the image that I sent you yesterday. Now, the way primitive values are checked, we have two variables there, hello and number variable, sorry. Both of them hold a primitive value. It doesn't matter if the values are the same. Hello could have been a string, number variable is a number, since I already named number variable. I won't say let's put a boolean into a variable called number variable. So let's imagine the variable hello holds a value of hello world string. Number variable holds a value of 34. We're comparing these two variables together. Both of them contain primitive values. What gets compared?
The value.
The value. Primitive value equality check. Now, referential types is quite different from that. Now, again, we're creating an array. So I did not update the reference. Okay, sorry about that. This should have said reference to empty array with one. So now we create two arrays. We could have created two objects. We could have created two functions. We could have created an array and an object, whatever combination it is of referential types. In this example, we create two arrays. Both of them have one single element, which is one, number one. Now, both of these variables contain kind of the same value. It's still an array of the same element, which is number one. However, both of them point to different parts of the memory. The references to these values are different. Now, in the primitive case, still the references to actual parts of the memory can be different, and usually they are different. However, JavaScript knows that the values of your variables are primitive types. And the comparison of primitive values, primitive types, works in a way that that the actual values are compared, not the references. In the case of referential type, however, this is the biggest difference between them, is that in case of the referential types, still our variables might, well, not might, but they hold references. They kind of point to the exact places where our objects, arrays, functions, whatever they are defined. But even if we would put the same array object in the variables, the references are different. In case of primitive values, the references are still different, but when we compare them, the values get compared. In case of referential type, references are different, same values, different references that point to different directions. Now, when we compare referential types, we compare the references, not the values. And that is why, even if the actual value in the variable is empty array, same elements, whatever it is, they will always be not equal. Okay, if we create our arrays this way, okay, even if we would just compare an empty array is equal to an empty array? No, because even if both of those are empty arrays, they are created in different parts of the memory. Hence, their references, their numeric references is different. They are now arrays is a referential type. We compare references. References are different. False. Yeah, and then I showed a way to get the same reference, right? So we've created array 2, which is an array with one element. We created another variable and assigned the value of array 2 into that variable array 3. Now, since array 2 holds the reference to the array, and now we're putting the same reference into another variable, and then we're comparing them. Now, both array 3 and array 2 actually point to the same place in the memory, right? So references are the same. This is the difference, and this is the key point. Now, when we compare array 2 and array 3, as we have created array 3 with this assignment operator, right? We said whatever it is, whatever reference it is in array 2, put it in array 3. The references are exactly the same. Now, when we do the comparison, we get true, okay? The difference between the referential type and the primitive. What was your question again?
Variables.
I was wondering if the parameter name gets the same reference as the function has, or the same value, or the value to this reference.
Okay, cool. Let me just remove all this stuff. We don't need that. Now, I'm going to slightly modify my my function here. I'm going to remove this default parameter, default value for the array. Now we will guarantee that we always receive an array, so that way we don't need these ifs, whatever it is. We're just doing some logs. And what I will do next, I will push a value into this array, okay? So this is a new value. Boom. Now let me create an array. Array, whatever array it is, 1, true, string value 5. Now what I'm going to do, I'm going to invoke my function. So this is called calling function or invoking function. Both of them are correct. I usually say to invoke a function. So what I'm going to say, what I'm going to do, I'm going to provide my array to this function. But before that, I'm going to console log my array, console log array. And what I'm going to do next, I'm also going to console log my array after this my function was called. Now, let me explain how this will work. Now, the way referential types work in JavaScript, that's why we discussed the primitive and referential types yesterday. Now we have this function. Let's imagine we have any function. However, in this case, we have this my function and we are providing an array. Now, this array, it seems like a variable, right? So it's a keyword and we can access the input value somehow, okay? And interestingly, the name of our input argument can be very different. I named it the way, but it's array of any values. This still works, okay? This will still execute. This is correct JavaScript. As you can see, the name of the input argument is different from the name of the array that we defined here. Now, to put it in simple words, now imagine what this means is we kind of create a copy of that array, but it's not a copy of the value, it's the copy of the reference. Why? Because arrays are referential types. Now, this array, this variable array, and the variable array of any value will contain the reference to the same array. So imagine if this is like const array equals array of any value. Imagine as something like this, okay? So now we know that array will hold the reference to the same array, not a new array, the same array. So if array holds a reference, if the variable array holds the same reference to array of any value, if I do this push, what do you think will happen?
I think the same, they will have the same value.
This array will be affected.
This array will be affected because the reference is the same. Now, as you can see, this was the original console log of the whole array, this one on line 19. This is our console log on line 10, blah, blah, blah. We do the for off, we log our values. and then we do the push. Now, as you can see, after the execution of our function, somehow we still have this value added. But since we know about the referential types and the primitive types, we know the difference. Now we kind of should understand why this works and why you should be very careful with passing referential types around and doing something with them in functions. And the same, it works the same way also with objects. If you would pass an object here, you would set a key value, right? If you would do something like this, the initial object, the original object, would be affected. So you should be very careful when dealing with objects, arrays. That is why, for myself, to guarantee that I will never modify anything outside of my functions, I usually create a new array and return that, or do whatever I do in that new array, or I create a new object and do something in that object. Okay, so referential types. What if, okay, I'll not show an example with the primitive types because it's like super simple. If you would pass 1, imagine my function does some other stuff, not for off. We can do for off on imagine it receives a number and adds a number. So if we would do the 1 plus whatever that number it is, our original value would not be affected because it's primitive type. When we do the copy, when we would do copy, let's say number value equals to const numeric value 1. So if we would pass numeric value here, imagine number value to be defined this way, which means put the value of numeric put the value of numeric value into the number value. But since this is a primitive type, we don't pass around the references in that sense. And if we would change the value, and then if we would say number value, which is the input argument of this function, is 20, the value of numeric value wouldn't be changed because it is not the referential type. So the interesting case is, and the case to be aware of, is the referential type. With other types, you don't have the problem. For the primitive types, the input arguments are basically clones of these values. And when you change something in your input argument, which is a primitive type, the original one that you pass out from outside that function doesn't get changed. So.
A quick question. When you write in the argument array, does it mean that the input should be an array, or this is just a naming or object when you write object?
It's a naming. It's simply naming. As I already said, if you would write object, or you would write array, or you would write string here, this does not guarantee that you will be receiving a string. This is just for you, your code reviewer, just so you know that you are expecting to receive a string or whatever it is in that argument. So it's just for your information, let's put it that way. Okay.
And if you write, for example, before the argument name upper letter string, it will not become a type like in other languages. In JavaScript, we don't have that kind of arguments to give a type to it.
No.
Okay.
Well, not. However, there is a convention. If the first character would be in uppercase, you would expect that this is a class or something like that, but no, we don't have that in JavaScript. Okay, let's do 10 minutes of break and then we'll continue. Okay. Now what we're going to talk about is that we can receive not only one argument or parameter in our functions, but multiple ones, and we can do something useful with them. But if you recall, as I was explaining, our functions may have inputs and also may have outputs. So far we discussed the function, right, or my function, and we've seen that we can receive an input and do something useful about that. However, we didn't discuss about the outputs. Now we're going to do that to kind of complete the whole function discussion at the moment. So we have the same my function here. What I've done is I just changed the logic of that my function. Now I say that we receive an array of numbers. We have that guarantee, so we don't have to have the guards. We don't have to check if the variable array of numbers is actually holds an array, if it's an empty array, whatever. We don't have to do the checks. So you have that guarantee from me. And the second thing what we're going to do is we're going to receive this value called threshold. Now let's see what my function does. It maps through. What does the map do?
Returns a new array.
Returns a new array. Is the length,
The same.
are the same? Okay, so the map returns a new array, and the length of that array, the number of elements in that array is equal to the original one. So we use map to basically transform all the elements in our original array. That's the use case of .map. So let's see what we do here. We do the map on our original array of numbers, and as we learned about functions, our .map receives a function, right? This is .map, it receives a function. As we can see, as we now know, functions are normal values in JavaScript. They can be passed around, and we're passing around this function into our map function. And what we receive as the first argument of that function that we pass to the map, we receive our element. And in this case, I'm kind of now saying that we will be receiving number elements because our object is, our array is an array of numbers, as we can see here. So the individual elements will be numbers, hence the name of the variable. And now what we do is we check if the number element is bigger than the threshold, we add 2 to that number element. So the way it works, we pass the array to my function, we set the threshold, we will be going through all the elements of our array, we will be checking each individual element with our threshold, and then we will get some kind of result. So if we would do manually, it would be the first element of the map would be 2. Is 2 bigger than 2? No. Then we will not do anything because we do not have an else but statement. Now, the second element in our array would be 3. Is 3 bigger than 2? Our threshold, the second argument, right? So we separate the arguments in the function definition and also when we invoke the function with the comma. Comma is the way to separate your arguments. So we say pass the array to my function and also pass 2 as the value of this variable, or let's call it argument, and pass 2 as the value of threshold. Now the second element is 3. Is 3 bigger than 2? Correct, it is. Yes, so we do the increment. Is 4 bigger than 2? Yes, we do this operation. Is 1 bigger than 2? No, we don't do this. And we don't do anything because we don't have an else. And it works the same way for our other elements. So now our intention in my function, now we have the inputs, right? We have the array of numbers, we have the threshold, we have our logic. Now the intention in my function is to return the mapped, the transformed array, right? So we need to do 2 things. We need to return the new transformed array of numbers from my function. We somehow need to pass the transform. I already gave you the hint, but the intention is to kind of pass that new transformed array of items into the outside world, outside my function. And in this function, in the function that we pass to map, we also need to pass somehow these incremented values, right? So that way we will be able to do the transform. Now, the way to do that is to use another keyword, which is called return. So to guarantee or to have this output part, we use that keyword return. So if we say we need to pass the new array into the outside world, outside to my function, as a result, we just return whatever we need to pass there, right? So the result of dot map will be an array. Now we want to pass that new array to the outside world, we use return. So we say return this new array to the outside world. Now we return the array. However, if we save this, you can see that all the values in our resulting array here, and the way we receive this array from inside my function, the result of our function invocation will be what we receive from that function. So that's why we have the line 18, right? So I invoke my function with the array and the threshold, and the result is assigned to a new variable called result, and that's what we logged here. And as you can see, all the elements are undefined. Why? We shall see that in a moment. But let's look at our function here. Let's look at the logic. So we say if number element is bigger than threshold, then increment it. But I think we also should to pass that incremented value to the outside world. So we forgot the return here. But is this still correct? This is not 100% still correct. Why? Let's take a look. Now, we have a pattern here, okay? Some of the values are undefined, some of the values are not undefined. You may think this is kind of chaotic, but it is not, because we have a pattern. Let's go by one, element by element, and see how this works. Now, we pass array to my function, and then we say our threshold is 2. Now we start mapping through our array, and as we can see, the very first element is undefined. So let's see what's wrong with that element. We come to line 11. For the very first element, the value is 2. Is 2 strictly bigger than 2? No. But as you can see, we don't have the else statement here, so kind of nothing happens. So what this means, when you do not have a return statement in your function, it means basically return nothing, return undefined, okay? I do not return anything from this function, and such value in JavaScript is represented by undefined. But what do you think we should do in the—
Return number element.
Yes. Correct. So we should return the number. Well, the intention of this example is to increment all these values which are bigger than threshold and do not modify the rest of the values. So now when we do this, everything is correct. But we could have done this in another way. We could say else and put the return in there, right? So this would be actually kind of the motive to do it, right? So we have an if, where we return the incremented value, and then we have else, and then we'll also return the number element. However, this could have been even better, and we actually had that in the first place. So I just naturally wrote the better option and then came to the original example that I wanted to explain. So the way we can do this, right? We may not write the else statement if we have a return. I'll explain why. Now, let's talk about the for loops. How can we terminate the execution of a for loop?
With break.
With break. So think of return as the break keyword of functions, okay? So when you see a return, whatever happens next of that return will never execute. It will simply never execute. You will never see this console log. As you can see, my editor even grayed out that code, which means you will never execute. You will never see the console log there. If I would move this, now I will see the console log. So Now that we know that the return keyword in functions is kind of the break keyword in the for loops, it just breaks the execution, stops, terminates, halts, it does not continue, doesn't do anything else. Now, with that knowledge, now having that knowledge, let's again take a look at this if. Now, what we do here is we say, if number is bigger than our threshold, return, meaning if there is an else, there is a console log, whatever there is, will never execute. Okay, so in the else, we have another return. So if we hit this return, will we ever hit this else? No, we will not. So we can just remove this part. And logically, both of them are kind of equal. Why? Because if we hit this if, we have a return anyway. So we will never continue to execute the other lines. So we may skip that else. And this is called short circuiting, right? So we basically just kind of skip the else part. It does not make sense to have it because we will never get there anyways if we are in this if. So we can just write it this way. This is just a trick. This code is acceptable. This code is acceptable. However, it's not that professional to write in this fashion. I'm just letting you know. This one is much better. It is less tough to type. It shows that you have the knowledge that return is the break of function. So there is no any idea to kind of have an else there. It doesn't make any sense. So in this case, we can skip. However, it's only this case that we can skip. If we would do console log 1, we would have to have an else because console log does not break the execution. Okay? So if the number element is bigger than threshold, then we should console log 1, otherwise console log 2. Now, if we would just put it here, what happens? Both of them will be logged because console log doesn't break the execution. So this tip applies to only the return keyword. Okay. That's about returning stuff to the outside world. So, so the basic function of summing two numbers, number 1 and number 2, would look something like this. Return number 1 plus number 2. Then if I would console.log sum 1 and 2, I would see 3. If I forget to put the return here, what I will get is undefined. Okay. But what if I write return and semicolon? What do you think this will return?
Yeah, because it returns nothing.
Yes, it will return undefined. Again, kind of same thing. So if you do not have an input, if you do not have in your a return in your function, that is called implicitly returning your function because you don't have the return, but the undefined is still implicitly under the hood returned by your engine. And if you have this return and semicolon, this is explicitly returning from function, stopping the execution of your function. And again, the same undefined value will be returned. So this is the explicit option. This is the implicit option. This is usually used when you do some kind of validations in your functions. So, for example, let's do something like this. What if we always need to have a guarantee in our sum function that number 1 is always smaller than number 2? Otherwise, don't do anything. So we can write it like this. If number 1 is bigger or equal to number 2, return from this function. Don't do anything. If number 1, so the condition was the number 1 should always be smaller, strictly smaller of number 2 to do the summing. Now I say if number 1 is equal or is greater or equal to number 2, return, don't do anything. or maybe return 0. It's who kind of decide what should we do here. In this case, I would simply return 0 to just keep the returning value of sum also a number, because in here I will be doing return number 1 plus number 2, and we will have 3. If I say number 2, number 1, 2, 1, I would get 0, or I can return null, or whatever it is, to kind of communicate to the outside world that something's wrong here. Or I can even say undefined. I can explicitly type return undefined. This is the same as return. Both of them are the same things. So that's about returning values. Now let's see if I pass 1 as the first argument, and then I pass 2 as the second argument. So in this case, everything works. But what happens if I would change these arguments here in the function definition? The logic changed. What happens, on the other hand, if I would change the values here? The logic is still the same. So what I'm trying to show is that the order of the arguments in function is very important. If you are expecting a string as the first argument, and you are expecting a number value as the second argument, and let's do the console.log. String and number value. This is your expectation. You expect a string, hello, and you expect a number. That is correct. And as you can see, the console log also says undefined because we do not return here, and that's why, and we console log the result of the function sum, hence we also receive the undefined. But let me maybe do like this, and we'll have only one console log. So we have hello and we have 2. Now, if we change the order of the arguments, now I'm passing 2 as the first argument, and then passing hello as the second argument. However, our expectation is that the string should come in the first argument, and the number will come in the second argument. And when I save, as you can see, the places of the values are changed. So the order of which you pass your arguments to your function is extremely important in JavaScript, okay?
The text is undefined.
Pardon?
The text is undefined as a parameters function. So it doesn't mean that we name the first one the string, we still can pass the number. If we want to resize the type, should we use TypeScript?
Yes. That is correct. However, even in TypeScript, if you say my first argument is of type of string, there is still a way to fool TypeScript and say, I'll pass whatever I want, okay? So TypeScript will not kind of block you from doing things like that. However, as we have seen multiple times, TypeScript provides a lot of value because if I would not pass anything here, TypeScript would say, hey, I know that your function sum expects 2 arguments, but you are not passing anything here. So this is TypeScript.
Yeah, but the TypeScript will show in the hint the required type.
That is correct. It will show if we specify the types. Well, but what I'm trying to say, even if it shows the types, even if you know the types, there is a way to override all that. So we're talking JavaScript. So my point was that the order of the arguments is extremely important in JavaScript, okay? So don't forget about that. Now, there is a way to kind of circumvent this, as I said in one of our earlier lessons. And since we've learned about objects, what we can do is we can expect an object of values here. Now, we can grab these strings as a key, object of value dot string and object dot of value dot number value. And what I can do here, I can pass an object here. So I can say my string is hello, and my number value is 34. And it still works the same way. Now, if I change the place of the keys, everything still works because we are talking objects. And in the objects, the order of the keys is not super important, okay? If you would just change the order of the keys, the key is still in there. So you can grab that key by the dot notation, and the other notation would be the square bracket notation. So we can grab it however we like, and it still works. And an added benefit here is that when you pass your values as an object, you kind of specifically spell the key. So whenever you provide a value here, you know that it is the string's value, okay? So, and in this case, we say hello and we say 2. But if you would like to know, okay, so what is 2? What is that 2? What does it represent? If you read this, you cannot tell because it's simply 2, okay? You don't know what it is. But in this case, you will have to spell the key, and now you know that this is your number value, or this is your threshold. Okay, so you read this, and now you immediately know that the value of my threshold is 34. And in this case, if it would be 34, you look at this, you don't know what 34 is. It's a magic kind of value for you. Okay. So that's about returning values. Yes, and the last topic that I would like to discuss is a new syntax of functions, new starting from 2015. Yes, sure.
About how can we define required and optional? Is it important to be
With question mark? Question mark of change.
Are we talking JavaScript or are we talking TypeScript? Because as you see, I'm not these kind of I'm not talking TypeScript that much because I don't see we're moving fast enough for the JavaScript to also talk TypeScript, because it would be more information which might be harder to understand. So are you talking TypeScript or JavaScript?
Speak about the late part of it to our definition testings everything in TypeScript.
Yes, I know. So maybe you will talk more TypeScript in the Cypress course or something like that. But what I'm actually my intention initially was to talk Git, to talk TypeScript, JavaScript, to talk about the DOM, the object document object model, to talk about query selector, to talk about HTTP. But I don't see we are moving as good as I would like us to move. And I want these core concepts. I'm just being honest with you, okay? I want us to have these core JavaScript concepts to be learned as good as possible. And if you have a good foundation, you can start learning Cypress, TypeScript, blah, 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 blah. These are tools. All of these are tools. If you don't know how to use .map on an array, TypeScript is not help. It cannot help you. Even if you know that you can specify the type of your variable, you can make it a number. But if you don't know how to map on an array, or how does it work, how does the reduce work, how does the object work, what is an object, what is an array, what is a referential type, what is a primitive type, if you don't have these fundamental building blocks, TypeScript, Copilot, all of this is just blah, 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 okay?
So how to define required and optional parameters in JavaScript?
You cannot define optional and required parameters in JavaScript because, as I have shown, well, you can define optional, and it was the, I'll show you. Okay. So we have this function called sum. I can call this function like this. It will break, but I can call this. This already means that there are no required arguments in JavaScript because you can simply call your function sum, which actually expects at least one argument. Well, in this case, one argument exactly. As you can see, TypeScript gives me the warning. It says, hey, one argument is expected, but got 0. You might have some problems, and we have problems here. But in JavaScript, when we are talking JavaScript, you can still do all this, and in that sense, there is no required arguments. Okay, so again, that's why we come to the idea of guards. That's why we come to the idea: is the value of this an array? If it's an array, do something with the array case. Else, if type of is string, do something if object of value is string, etc. Okay, so that's why we have this kind of guards in our functions, because there is no guarantee of the type of the value. Even there is no even guarantee that you will receive a value. Now, in this case, since we expect that our value, that our incoming value, the input value is an object, and we're trying to read the string and number value properties on that object. However, in this case, I did not pass the object, which means I passed kind of implicitly an undefined. Now, object of value is an undefined, and this is an error. You cannot read dot string and dot number value on an undefined, on a value. It will give you an error, as you can see here. So it says you cannot read string on undefined. That's why you will have to. That's why you can do this this optional kind of value thing, right? You can say if my kind of input value. Yes, TypeScript. Thank you very much. Sure. Let's silence you for a second, okay? So you can say if my incoming value is an undefined, at least provide some kind of initial value to that argument. So, and in this case, if the incoming value is undefined, we have an empty object, and the dot string or dot number value of an empty object is undefined. So this is the optional kind of value case. You can say threshold. For example, your threshold is the required value. What you can do in JavaScript, you can say if not threshold, then throw new error. For example, one of the options, error threshold, the value of threshold is falsy, whatever, I have a typo. So this is the way in JavaScript to basically guarantee that if the value that you think is required but it is not passed, or a falsy value is passed, or the value that it is passed does not satisfy your validation. So for example, you can say if not threshold, so which means if no threshold is passed, or if the threshold is passed and threshold is bigger than 5, give me an error. So if the threshold is not passed, we have an error. If a threshold is passed, but the threshold is bigger than 5, we still have an error. So all these type of validations, it's a required field. All this is done in JavaScript as a code. In TypeScript, yeah, you can say this argument is required, and if you don't, if you invoke your function and don't pass that argument, TypeScript will say you have an error. However, if you suppress TypeScript, as I did here with tsignore, you still get a normal JavaScript, and that JavaScript will still break down if you do not do the validations like here. So no required kind of arguments. The optional ones are these, where we provide the default value. By the way, optional arguments cannot be in the beginning by itself because they are optionals, or I think it was maybe not in the beginning, but in the middle. Anyways, there was something like that. So can we say hello? Pretty interesting. I'm pretty sure in my project, if I would put the optional on the first place and the other one was not optional, that would be okay. So maybe that's not a JavaScript error, but it was some kind of linting or validation in my project. Never mind. So in this case, if you look at the arguments, this one is your optional argument, right? In quotes, the optional one. And this one can be treated as the required one. And for the required one, the required ones, you usually will have to have some kind of validation, manual validations in place.
And in the case of reduce function that we have like several arguments there, like current value, accumulator, and array index, we can like give some and some not. I mean, those are the optional ones. And just to know, is that the overriding or overloading of methods, or there is no something like that in JavaScript? Because
yes. We do not have the concept of overloading in JavaScript like you would have in C#, for example. I'm not that familiar with other languages. Maybe in Java, you also have the overloading. The overriding we do have in JavaScript, so you can very easily override keys of the objects. You can easily override the values in your variables. So that's that.
Okay.
Now what I'm going to do is I'm going to write the same, we have 7 minutes to go. I'm going to write this same sum function, but in another syntax. So the new syntax looks something like this. Number 1, we still have our number 1, and then we still have our number 2. And then what we do, we return number 1 plus number 2. Now, let me just also write the same thing in, as a normal function declaration, number 1, to kind of show the differences. The difference between these two syntaxes is slightly bigger than what I will say right now, but we'll get there when we discuss classes. So, okay, as you can see, the curly bracket part is kind of the same, so no changes there. The only difference is in here, we do not use the function keyword. We kind of define a new variable like similar to one that we did with this, right? I can also put this type of function declaration. Now, this is the first one that we learned. The second one we learned was this one, and these two are kind of closer, so that's why we'll discuss these two, the transition from this one to this one. So this is the normal, these are some normal function declarations. Now, this type of function declaration is called arrow functions, and arrows because of this. This is the equal and greater signs kind of combined together, and that is why it's basically called arrow functions. In JavaScript, in C# they are called lambda functions, and I don't know how they are called in other programming languages. Now, the difference between syntax, again, the curly brackets, basically the same, so nothing new to learn. As you can see, the parentheses and the order of our arguments and our arguments itself are still there, so no changes there. Basically, the difference is we remove this function keyword, and then we put the arrow, the equal and greater than sign, and we get that arrow there. And we basically just transform the normal function declaration into an arrow function. Okay, so I will just copy paste this, and I'll put this into our group. So this is called arrow function. Now, a nice thing about arrow functions, if you do not provide this curly bracket, it will simply return the value of your expression. So if I would just comment out this part, I'll do console log of sum 1 and 2, we will get 3. This is kind of the one of the biggest differences, because in functions there is no way to not specify the curly brackets. However, in arrow functions, you can do that. You can also say curly brackets, number 2, return, and also you can say, let's copy paste the same thing. And also you can say, my operation is very simple. I don't need the keyword return. I don't need the keyword, I don't need the curly brackets. So I simply say, whatever the operation, whatever the result of this operation is, just simply return from the function, and that's what we get. I will comment this out, and we get 3. Then I will comment the other one out, and we still get 3. So functionality wise, in this case, they basically both return the same thing. This is also implicitly returning your value. And of course, in arrow functions, if I would just write the curly brackets but not return anything, I would still get an undefined. I mean, whatever you write in curly brackets, it basically works the same as we have in our function declaration. So nothing new there. Yeah, so this was the second kind of syntax, the new one of defining functions. As you notice, we didn't do any kind of tasks during the session, which means you will have lots of homeworks. Maybe you will also have a quiz. We shall see. We have a few minutes to go. If there are any questions, please go ahead. Otherwise, I will start recording and we will stop today's session.
May I ask, so the last syntax is used when we have short expression after an arrow. If we want to write a lot of code, we use the short.
Correct. Yes.
Just like not very detailed, but like high level, can you like tell us about the behavior of arrow functions, like comparing with others, like how it works, like the difference between?
We'll talk about the difference when we get to classes.
Okay.
Okay, so we'll have to end the meeting. Thanks, everyone.